In this video, I will show you the differences between a major in math and physics, and the things to consider about both majors. According to PayScale, the average pay for someone with a bachelor's degree in mathematics is $77,000. And also according to PayScale, the average pay of someone with a bachelor's degree in physics is $87,000. The difference could be because a physics degree is slightly more applied towards job functions than a pure math degree. Since mathematics is used in many different fields, a math degree should open you up to many different job opportunities. According to PayScale, the most common reported jobs people with a math degree report having are software engineer, data analyst, data scientist, math teacher, actuary, financial analyst, and a data engineer. However, a math degree is a somewhat general degree that is not specific to a certain type of job, in the way something such as computer science is to software engineering. If you do end up choosing a math major, this means that you should take courses from the field that you want to enter, do summer internships, and to complete projects related to that field as well, in order to be competitive when seeking a job. It also means that alternative majors, such as computer science or the different engineering majors, are likely to give you an easier time when looking for a job after graduating. This is also shown in the data, since computer science and the different engineering degrees both report having higher average pay than mathematics. Many math majors go into software engineering after graduation. If you want to qualify for software engineering jobs, then it would help to make sure to take a class in data structures and algorithms, since the material from that class gets tested heavily in software engineering interviews. It would also help to try to get some internships as a software engineer while in college, and to complete software engineering projects as an undergrad. The three most common reported jobs for people with a math degree are software engineer, data analyst, and data scientist. All three of them involve the use of programming, so it would help to make sure to learn to program regardless. The Bureau of Labour Statistics predicts that the demand for mathematicians and statisticians will rise by 33% by 2029. This is mainly due to the surge in data that companies have been receiving in recent years, that they need people with mathematical and statistical skills to make sense of. Currently, data science is becoming a very popular career path among math majors. To qualify for data science jobs, it would help to make sure to learn Python programming, data analysis using the Pandas library, machine learning, and to complete data science projects as an undergrad, and to try to get data science internships. If your university does not offer classes in data science or machine learning, you will need to self-study them using books and websites such as edX, Coursera, FreeCodeCamp, Kaggle, or DataCamp. According to data from the American Physical Society, in 2014, only 5% of people with a bachelor's degree in physics got a job directly related to physics. 36% ended up in engineering roles, and 23% ended up in computer information or systems roles. This means that it will likely be difficult for you to find jobs directly related to physics, and you will likely need to look for jobs in other fields. You can improve the job prospects of the major by taking classes that are related to certain types of jobs, or getting a minor in a more applied field, such as computer science or engineering. According to PayScale, common jobs people with a bachelor's degree in physics report having includes software engineer, data scientist, physicist, research scientist, data analyst, mechanical engineer, electrical engineer, optical engineer, process engineer, and a manufacturing engineer. Many of those jobs will require a more advanced degree, including physicist and research scientist. Many physics majors get jobs in engineering positions. However, many of them likely actually went on to get a master's degree in areas of engineering or took a lot of engineering classes as undergrads. Also, it will be more difficult to get a job in engineering with a degree in physics than with an actual engineering degree. Physics majors also often end up in software engineering positions. As with a math degree, a physics degree can become a lot more employable if you combine it with a computer science minor and software engineering projects. Data science is also becoming a popular career path among physics majors, and it would also help to combine the major with data science, statistics, and machine learning classes where possible, and data science or machine learning projects. If you choose to major in physics or math, it is very important that you choose your electives according to the jobs you are interested in, and to self-study where needed. If you only rely on the required classes in math or physics, it will likely be difficult for you to find more specialized jobs that pay well. Both majors combined with computer science, statistics, data science and machine learning classes, as well as projects in software engineering, data science and machine learning, would make them both a lot more employable. This is because software engineering, data science and machine learning engineering are all quickly growing job roles that have high pay and a high number of total jobs available. As a math major, you will be taking courses primarily from mathematics. However, you will also have the opportunity to take classes from computer science, physics and statistics. Some classes you can expect to take in your freshman and early sophomore years include single and multivariable calculus, linear algebra, discrete math, introduction to computer science and introduction to physics. In your junior and senior years, you can expect to take advanced math classes including differential equations, abstract algebra, real analysis, graph theory, complex analysis, topology and number theory. In a physics major, you will need to take a number of math classes in order to take some of the more advanced physics classes. You can expect to take math classes such as differential calculus, integral calculus, multivariable calculus, differential equations, linear algebra, and partial differential equations. You can expect to have the option to take more advanced math classes if you would like. You might also have the option to take classes from related disciplines such as statistics, engineering, and computer science. You can also expect to take physics classes including Introduction to Physics, Mechanics, Electricity and Magnetism, Quantum Physics, Statistical Mechanics, and Thermodynamics. The math major is generally considered as being one of the hardest undergraduate majors available. It becomes especially hard when you enter your junior year since most of your classes will be proof-based, which tend to be much harder than the more computational classes. If you choose applied math instead of pure math, you will usually have more computational classes, but there will still be some proof-heavy classes as well. A pure math major will have a lot of proof-heavy classes. A physics major can also be a very difficult major, and you will likely have to put a lot of time into the major. In physics, you won't usually have any proof-based classes, but the physics classes themselves can be difficult. Ultimately, you should expect both majors to require a lot of study time. While a math major is not as applied to a specific type of job like computer science or the different engineering degrees are, it can still be very employable if you combine it with a minor in something more applied such as computer science, or take lots of applied electives. Also, math can be very useful when applying to graduate school, as it is a lack of math classes that often makes students less competitive. Although, again, it will still be important to take classes related to the discipline that you are interested in. The same could also be said for a physics major. Also, instead of a pure math degree, an applied math degree would likely be a better option, especially if you do not know if you like proof-based math classes yet. An applied math degree should also put you in a better position when searching for jobs. I have another video on my channel comparing a pure math degree with applied math. When compared with a pure math degree by itself, a physics degree will usually qualify you for more jobs by itself. If you like mathematics but you have not taken a proof-based math class, there is a high chance that you will actually find that you like the math used in a physics class more than in an advanced math class. This is because the math used in the physics classes will generally be much more applied and computational than the math used in advanced math classes. Ultimately, both majors have a lot of similarities. They can both be difficult to find jobs with by themselves. They are both very difficult majors. They will both qualify you for very similar jobs. They can both be helpful when applying to graduate school if combined with the appropriate classes, and they can both be made a lot more employable by taking classes relevant to specific job roles. It would help a lot to think carefully about the type of jobs that you are interested in and to take classes related to that job. Also, instead of majoring in physics or math, an alternative that would be worth researching would be to major in a more directly employable major such as computer science or engineering, and to minor in physics or math instead.